Hello everyone, in this video tutorial, we will see how we can do license plate detection and recognition using YOLO-NAS. So here is the complete notebook script. I will be guiding you step by step on how you can do license plate detection and recognition using YOLO-NAS. For license plate detection, I will be using YOLO-NAS object detection model, and to read the text from the license plate, I will be using EasyOCR. So to detect the license plate, I will use YOLO-NAS model, and to read the text on the license plate, I will be using EasyOCR. So let's get started. So here you can see that we have the license plate dataset over here. The dataset consists of 300 images, and here we have the air ratio. Like we have 601 images in the training set, 64 images in the validation set, and 30 images in the test set. And the splitting ratio is 80%. 6% of the images are in the training set, 9% of the images are in the validation set, and 4% of the images are in the testing set. And if you just see over here, we have only one class in this data set, which is of lessons. And here you can see the images. So you can see that we have only one class in our data set, which is of lessons. We don't have multi-classes. And here you can see that a bounding box is being created around the lessons plate in the images. Like you can see over here, bounding boxes are created around the lessons plate in the images. Like you can see over here, you can see over here as well, and you can see over here as well. Like bounding boxes have been created around the lessons plates. If I go to the next image, you can see that we have the bounding box around the license plate. So I will be training or fine tuning my YOLO-NAS model on this license plate dataset. So after training the YOLO-NAS model on this license plate dataset, we will be testing our model on images and videos, and we will be seeing whether our model is able to detect the license plate or not. So if our model is able to detect the license plate, then we will read the text on the license plate using EasyOCR. Okay, so you can see over here, I will just use EasyOCR to read the text on the license plate. Like here, we have MH20BQ20. So first of all, I will be training or fine-tuning the YOLO-NAS small model on this license plate dataset so that we can detect the license plate. And after detecting that license plate, I will use EasyOCR to read the text on the license plate. Okay, so here is the code. So before running the script, please make sure that you have selected the GPU. So I will just click on runtime and click on change runtime. And you can see over here, I have selected the hardware accelerator as GPU, and GPU type is T4. Okay, so in the first step, you need to install the packages. So I have already run this cell and installed the packages because it's a time taking and it take around 10 to 11 minutes to install the packages. So after installing the packages, we need to restart the runtime. So I will just click on the restart runtime over here and just restart the runtime. Then in the next step, I will import all the required libraries. So I will just run this cell and this cell and this cell as well. So now, after importing all the required libraries, in the steps 3, I need to set the checkpoint directory and just write the and create a subfolder inside that checkpoint directory where I will just save my best model weights, the model weights on the last epoch, and the average model weights. Plus, I will also save the log files in this folder as well. So now you can see here, I will be creating a directory by the name checkpoints, and inside this directory, I will be creating a folder by the name ANPR YOLO-NAS run. This is the name of the folder which I will be creating in this directory. And inside this folder, I will be saving the best model weights. The best model weights means the model weights on so on the specific epoch on that specific epoch on which the model gives the best performance or the best mean average precision. So we call these weights as the best model weights. So the best model weights are those weights on which the model give us the best performance. Okay, so if I am training my model on 15 number of epochs, so on the specific epoch on which the model gives us me the best performance, I will save those weights and call those weights as the best model weights. Okay, and then we have the last model weights. So in that folder, so the last model weights represent the model weights on the last epoch. So if I'm training by YOLO-NAS model on a sense plate dataset for 15 number of epochs, So the last model weights represent the model based on the 15th epoch because I am just training my model on 15 number of epochs. So the last model weights represent the model based on the last epoch. And then we have average model weights, and plus we also have the logs file over here in this directory as well. So I'm just instantiating the trainer over here. So I will just download this dataset from RoboFlow into the Google Colab notebook. So I will just click on overview from here and click on download this dataset and just select the YOLO v5 PyTorch format and click on continue. And okay, so now I will just copy this code from here and just paste this code into my Google Colab notebook. Okay, so I'm just okay, just remove this, it's double copied. So I have just copied the code from there, and you can see that I'm just added the code over here. So if you haven't created your account on RoboFlow, you can just create your account on RoboFlow, and this dataset is publicly available on RoboFlow Universe, and you can easily download this dataset from RoboFlow into your Google Colab notebook. So now you can see over here, I have downloaded the dataset from RoboFlow into the Google Colab notebook. Okay, so here is the dataset. Okay, we have the train, test, validation folder, and the test folder contains the images and their labels. In the label, we have labels folder. We have the coordinates for the bounding box for each of the image. And here is the data.yml file. Uh, you can see here we have only one class, which is of lessons. And here we have the training, validation, and test dataset images path. So in the images folder, we have the images without bounding boxes. In the labels folder, we have the bounding box coordinates saved in the .txt file, okay, for each of the image. So I'm just setting this data set as my current directory by just click on copy path from here and set this data set as your current directory. And then along with this, we will set the train images and labels directory over here, and then we'll also set the valid images and labels directory over here, and then I will also set the test images and labels directory over here as well. And as you can see in the data.yml file, we have only one class which is of lessons, so I have just written lessons over here. And then I'm just passing the batch size value, number of workers value in the dataset parameters, and I'm just running this cell over here. I'm just inspecting the dataset which I have defined earlier. So now I will just plot the images in that my training data with their bounding boxes to see how my dataset images look like. So I'm just plotting the images in the dataset with their bounding boxes to see how my training data images look like. You can see over here, we have drawn the bounding box around the lessons players. So you can see over here, we have drawn bounding boxes around the lessons players. You can see over here, we have drawn the bounding boxes around the lessons plate. So now I'm just instantiating the model. So now I will be training or fine tuning my YOLO-NAS small model on the lessons plate dataset. So I will be training or fine tuning my YOLO-NAS small model on the lessons plate dataset. YOLO-NAS comes with three different models: YOLO-NAS small, YOLO-NAS medium, and YOLO-NAS large. In this project, I'm using YOLO-NAS small model. So I'm just instantiating the YOLO-NAS small model over here, and I'm just using the pre-trained weights of the COCO dataset. And the number of classes, here you can see over here, if I just go above, in the dataset parameters, I have just defined classes, and I have only one class, which is of lessons. So the length of this dataset parameter classes will be one because we have one class in our dataset. Okay. So now before we start the training, there are a few mandatory arguments that we must define before we start the training, which include maximum number of epochs. So in the maximum number of epochs, you will define the number of epochs on which you want to train or fine tune the YOLO-NAS model on your custom dataset. Currently, in this case, we have our custom dataset as license plate dataset. So here we define the maximum number of epochs. Then we define the loss, whether we are using PP YOLO-E loss or any other loss. Then we define the optimizer, whether we want to use ADAM optimizer or RMS prop. And then we define the train matrix list, validation matrix list, and then we also define the metrics to watch. So here the metrics to watch will be mean average precision with an IOU of 0.5. So now you can see over here, these are the mandatory arguments that you must define before training. You like here, you can see that I have defined a number of parameters before training, but these are the 6 mandatory arguments that you must define for the training. You can see over here, I have defined the maximum number of epochs as 15. I have defined the loss as PP YOLO E loss. And further, I have defined the optimizer as Adam, and I have defined the initial learning rate over here as well. And the matrix to watch I've defined is as mean average precision with an IU of 0.5. So now I will just download some demo videos. So I place some demo videos into my drive. So I'm just downloading those demo videos from drive into this Google Colab notebook. So I will be testing my trained model on license plate dataset on these videos and see whether we are able to detect the license plate in these videos or not. So let's see whether we are able to detect the license plates on these videos or not. So now here you can see that we have the demo videos over here. So I have already trained my model on the license plate dataset. So I will not start the training again because training takes 30 to 40 minutes. So I will just save this time. I have already trained my model on license plate dataset and I have saved my model check best weights into the drive. So I will just download the best weights from the drive into this Google Colab notebook. So I'm just downloading the best weights from the drive into the Google Colab notebook. So you can see over here, it's downloading the best weights from the drive into this Google Colab notebook. So I've downloaded the best weights from the drive into the Google Colab notebook. So I've trained my YOLO-NAS or fine-tuned the YOLO-NAS small model on the license plate dataset. And here I've just defined my best weights checkpoints path. And you can see over here, here is our best weights path. I will just copy this path from here and just add this path over here. Okay. So I will evaluate the best trained model on that test dataset images and see what we get in terms of mean average precision and in terms of F1 score, recall score. So let's see. This might take few seconds. So after this, I will be doing prediction on an image as well. So now you can see over here, we have got an mean average precision of 90.88. So this is very impressive. The mean average precision with IIU of 0.5 is 0.9088, which is 90.88. And we have F1 score with IIU 0.5 as 0.1017. So I will now just click on validation and I will just take a random image from here, copy path, and just add this image over here and let's see whether we are able to detect the license plate in this image or not. So let's see whether we are able to detect the license plate in this sample image or not. Okay, it is given me okay, so let's see if it gives the error or it works fine. Okay, so just let me just copy this again. I might have missed something. So let's see how it works. So now you can see that we are able to detect the license plate in this sample image. And here we have the confidence of 0.79 and we have detected the license plate. Let us test one other image. Let's copy path from here. I am testing on this second image. And let's see, you can see over here, we are able to detect the license plate over here as well. So the results are fine. Let me test on some other image. So we are able to detect the license plate and it's working very fine till now. You can see this is wrong in this case. Let's test on some other image. And let's see whether we are able to detect the license plate or not. You can see over here, in this case, we are also able to detect the license plate, although there is a car crash. So now I will be testing my model on this video and let's see what results do we get. So now we will doing license plate detection on a video. And let's see what results we are getting over here. So the processing detection is done frame by frame. So this will take some time because the detections will be done by frame by frame. So this will be a bit time taking process. And let's see whether we are able to take the license plate here or not on this video. Okay. So now you can see here we have the detections.mp4. So here we have saved the output video by the name detections.mp4. So let me just display this output video over here. Okay, so just remove this. Currently, we don't need this. Mhm. So let's see whether we are able to detect the license plate in this video or not. And so I have just saved the output video by the name. Basically, I have done the detections over here. You can just remove this. We don't need this. So you can see over here, I have done the detection on this video over here. Now I'm just displaying the output video into the our in this Google Colab notebook. So I'm just displaying the output video over here in this Google Colab notebook. So this might take few more seconds before we have the output video ready, and then I will show you the output video over here. So here is our output video. Due to small screen size over here, we might not be able to see the output very clearly. Let me download this output video and share you the how our detection results look like. So let me just navigate my screen towards this output video. So now you can see over here, we are able to detect the license plate very clearly. Like detection results are very impressive. We are able to detect the license plate and the detection results look super awesome. Okay. So now you can see that we are able to detect the license plate in this video. We have also detected the license plate in random images as well. So now you can see that we have detected a license plate. Now I will use EasyOCR to read the text on this license plate. Okay. So now in the next part, we will see how we can use EasyOCR to read the text on these license plates. Okay. So we have detected a license plate using YOLO-NAS object detection model. So we have detected a license plate using YOLO-NAS object detection model. So now I will use EasyOCR to read the text on these license plate. Like here it is 66HH07. In the last part, we have seen that how we can detect the license plate using YOLO-NAS model. Now in this part, we will see how we can use EasyOCR to read the text on the license plate. So we have detected the license plate using YOLO-NAS. Now we will read the text on the license plate using EasyOCR. So first of all, you can see over here, I have created a folder by the name automatic number plate recognition. Now I will just go to the PyCharm. So here you can see that I'm in the PyCharm. I will click on file and create a new project over here. And here from here, I will just select the directory of the project. So inside the YOLO-NAS course, I have created a folder by the name automatic number plate recognition. So here our also location is also fine. We have creating a new virtual environment and our base interpreter is being set as Python 3.10 with Python exe. So now I am just creating a new project over here. So first of all, we have detected license plate. Now we want to read the text on the license plate. So I have saved my best model weights. So I will just create a new folder over here and just add the model weights over here. So now new and just create a folder by the name weights. Now I will add the model weights into this folder. Okay. Let me navigate my screen. Okay. So now you can see over here, I have just created a folder by the name weights over here. And inside this folder, I have added my best model weights over here. Okay, so these are the model weights after training. I've just downloaded those weights and just paste into this local directory, the best model weights. Okay, so now I will just go back towards the code. So now I will be doing license plate detection on some video because it cannot be done currently in live webcam feed. I'm just sitting in my workroom. So I will just create a new directory over here by the name video. And inside this video directory, I will paste a demo video. So I will let me just go to the video directory. So you can see over here, inside this, I've just created a directory by the name video. And inside this directory, I will just add this demo video. So we will be doing license plate detection on this video. Let me just show you what this video is. So, okay, so sorry. Okay, so let me just navigate my screen towards this video. So now you can see this video. So now I will be doing license plate detection on this video. So you can see over here, we will be detecting the license plate using YOLO-NAS, and using EasyOCR, I will read the text on these license plates. So let me just go back towards the code. So now here you can see that in the video folder, we have the demo video. In the weights folder, we have the best model weights. So we are on the track. So in the next step, what I will do over here is I will just create a .py file. Okay. So here I will just create ANPR, automatic number plate recognition, ANPR.py file. So now in this ANPR.py file, I will add some code of, so I will add the code for the of license plate detection using YOLO-NAS. Okay. So now here you can see that in this anpr.py file, I have added the code for the license plate detection. And we have only one class license, and we have fine-tuned or trained our YOLO-NAS small model on license plate dataset, and these are our model weights. So we have placed the model weights into the weights folder over here. And so just correcting this path, we have to go to the weights folder, and inside the weights folder, we have our best model weights. Okay, so now let's run this script and see what results do we get. So I will just write Python anpr.py, and let's do license plate detection on this video. So we are just testing for the license plate detection. After this, I will add code for the EasyOCR so that we can read the text on the license plate. But firstly, I'm seeing whether we are able to detect the license plate over here in this PyCharm or not. So if there is any error, I will definitely fix it, but let's see how it goes. So it has started execution. Okay, so currently I'm just getting the error. What is the error? The OpenCV Python. Okay, it should be output.avi. Okay, out.write frame. Okay, just skip this out currently. Uh, Let me just run this now. And let's see how it works. And if there is any error, we will fix it out. So it has started executing, and this might take some time for to complete the execution, but let's see. Okay, again an error. Let me just check it. So I have figured out the error. My basically this video path was not correct. So first of all, this is small v, so let me just correct it. And I just need to remove this as well. So now the video path is correct, and I have just done this, uncommented these lines. Okay, so let's run it and see what results we get. So basically our video path was not correct, so therefore we were getting the error, but I hope now it's fine and it will work fine. But if there is an error, we will definitely fix it up. So this might take a few more seconds before we get the results. Okay, so it has started executing and it's looking to work fine, but so now you can just let me navigate my screen towards it. Okay. So now you can see over here, we are able to check the license plate. and we have detected a license plate, and here we have the confidence score. So the next step what we want to do is we want to read this read the text on this license plate. Like here it is R183JF. So I want to read this text on the license plate. We have detected a license plate. But I want to read the text on this license plate. So I will just go back towards that code and just write the code for it, and let's read the text on the license plate. So to read the text on the license plate, I will be using EasyOCR. So first of all, I will import EasyOCR over here, and then I will initialize EasyOCR. So I will write reader is equal to EasyOCR dot reader, and we want to read the text in the English language. So currently the text is in English language, so I will write English, and I don't have GPU in my local system, so GPU will be false. Okay, so next what I will do is over here is, okay, I will just create a function by the name OCR-image over here, and the image in the input which we have for this function will be frame, the x1, the y1, the x2, the y2 coordinates. So these are will be the inputs for this function OCR image. And first, to read the text on the license plate, we just need to find uh, we just need to pass those coordinates of the bounding box. So here we just need to have x2, y2. Okay, so first of all, we will just want to have those that area from where we want to read the license plate text. So I will just write frame is equal to frame y1, y2, x1, x2. So now we are only selecting the area where we have detected the license plate. Now we just need to convert the area where we have detected the license plate into grayscale. So we just need to convert from BGR to grayscale. So I will write gray is equal to CV2 dot CVT color, and I will write frame, comma, CV2 dot color BGR to gray. So we are just converting that area from BGR to grayscale. Next, I will write reader, or I will write result is equal to reader. So now here I have initialized the EasyOCR. So I will write reader dot read text. So now I have converted my license plate area from BGR to grayscale. So now I am just reading that text in that area. So I have initialized the EasyOCR over here. So now using EasyOCR, I am just reading the text on the license plate, and my text will be stored in this result variable. So I will be showing you that print result. Okay, and okay, so I just leave it over here, and that's uh, go over here and just initialize the EasyOCR from here. So now what I will do is, first of all, just comment out this and just press enter over here. So now I will be calling this function below. So I will write text is equal to, just copy the name of this function from here and write text is OCR image, and I will pass frame x1, y1, x2, and y2 coordinates. And let me just print this text over here. Okay, so I'm just trying to print this result, and then I will show you how we can read the text and just display on the license plate the text. So let me just run this and see what results do we get. So I'm just executing the script and hopefully it will run, but if there is any error, again, we will try to fix it up. So it's executing, but it will take some time to complete the execution process. So let it complete the execution and then we will go ahead. So it is going okay. So okay. Okay, so I have just commented out the level, so yeah, you can expect that error. Okay, okay, okay. So I don't want to just show the output currently. Just comment this out. Okay, so let me just run. Let's see. Hopefully it will not print the results. I forgot to comment these lines. So I have commented these lines now. And let's see what results do we get now. So this might take few more seconds before we were able to see the results over here. Okay. Mm, mm, okay. So this is for the first frame and this is for the second frame. Okay, let's go for the 5 and then I will just pause this video and let's see. So here no license plate is detected. Okay, at the start. Okay, okay, okay. Got it. I got it. Okay. So basically we are just printing this text and here you can see this text over here. You can see this text over here. So now what we can see that here we have a list and inside this list we have this complete list over here. And here you can see that these are the coordinates of the bounding box, like we have drawn a bounding box or a rectangle around the license plate. So these are the coordinates for this rectangle. And here we have the confidence score. Like this 0.10 means the model is 10% confident that this is the license plate. And here 0.30 means the model is 30% confident that this is the license plate. And here is the license plate text. So this is the text of the license plate. So now we just want to display this text above the bounding box. Okay. So here is the text of license plate. And inside this list, we have this complete in the bracket. So we have only one term inside this list. Okay. So you can see over here, I have created a OCR image. So now I will just add few things and we will be able to display the text on the lesson split. So what I will do over here, let me just okay, no need to comment, just write text is equal to, okay, and then press enter over here. Now I will loop through each of the result for result, res in result, and I will just write over here, if length result is equal to 1. So currently here you can see the length is equal to 1 because inside this list we have the brackets and this is completely one term, one thing, okay? If length result is equal to 1, text is equal to res 1. Okay, so okay, so now inside this list, this is the one term and inside that this is the other term and then in the one part we have this, okay? And further I will write if length result is greater than 1 and length res 1 is greater than 6, and rest 2 means the confidence is greater than 0.2, then so in that case, we all will also print the text over here. Result 1. So that's fine. Print, leave the print now. Return string text. So that's fine completely now. Okay, so what next we need to do? Just display this text on the bounding box. And I will also save the output video. Okay, let's see if it works. Okay, I just want to change the color of the bounding box and the rectangle. So just give me a minute. Let me just look for some other color schemes I might have saved in my system. Okay, so just give me a minute. Let me look for these color schemes. So now I've just made the change in the color schemes over here and just added few different colors because it was previously appearing a maroon and it was not looking very good. So I've just updated the color schemes and let's see how it goes. So this might take a few more seconds and before we are able to see the results over here. Okay, so this might take a few more seconds before we have the results or the output in front of us. Okay, so here we get the label error and it is in line 60. Label. Okay, so that was my mistake. I've just not written. Label is equal to y. So label is equal to text. So hopefully it will now show the output over here and let's see. I think that error is now fixed and we will have the output now. So it has started executing and let's see what output do we get. So this might take few more seconds. So you can see here, I am using CPU. This module is much faster with a GPU. You can see this line over here. So if you have GPU in your system, that is best case. So let me just, so now you can see over here, we have detected the license plate. Okay, let me just navigate my screen. Sorry, I again forgot to navigate my screen. Okay, so now you can see over here, now you can see the result. We have detected the license plate. Plus, I am also displaying the text on this result plate like R183JF. So we have detected the license plate, plus we are also able to display the text on this license plate. So that's amazing. In this way, we will detect and read the text on the other license plates as well. So currently, I am using CPU, so the detection is very slow. But if you just follow this format, you will be able to detect the license plate. Plus, you will also be able to read the text on this license plate as well as we are doing over here. So we have detected the license plate. We are able to read the text on this license plate as well. So in this way, we will be able to read the text on the other license plate of different vehicles as well. So that's all from this video tutorial. I hope you have learned something from this video tutorial. See you all in the next video. Till then, bye-bye.